20%, then at the end of year one, it would have been 20% of a million, which is 200,000 plus that 1 million. So at the end of year one, that's $1,200,000. And now investing at 20% again for year two, at the end of year two, that works out to be a little over $1.4 million. And at the end of year three, it works out to be this figure. At the end of year four, we're up over $2 million. And at the end of year five, again, 20% of this number added back to that number works out to be this number. All right, so the same $1 million invested at 10% for 5 years works out to that number, or invested at 20% for 5 years works out to be a much higher, more impressive number. And that's the whole idea of internal rate of return. So with the internal rate of return, we're trying to figure out what is the annual interest rate that we would have to be making on the investment in order to get the benefit at the end of that period of time. All right, let me say that again. The real question that we're asking by computing the internal rate of return is, what is the annual interest rate on the investment that we would have to get in order to yield the benefit at the end of the period of time, which works out to be the lifetime of this proposed IT system. All right, so if we go back to this example and we ask the question, so is this a good investment? We're going to go to the CFO and ask him for $1 million, and we're going to return him $1.5 million in 5 years. He ought to be impressed with that. The CFO is going, I'm not impressed at all. That's a measly 8.4%. There's got to be better things we can do with our money than invested at 8.4%. Okay. On the other hand, if you were to promise him $1.5 million after, let's say, 2 years instead of 5 years, well, let's work that out. Okay, that's internal rate of return is equal to the benefit, again, $1.5 million, divided by the cost, which is $1 million, raised to the 1/2 power minus 1. Okay, let's go back to the calculator again. So we have 1.5 raised to the 0.5, which is 1/2. Okay, that turns out to be 1.22 minus the 1 here. All right, and we're left with 22.5%. All right, so this works out to be 22.5% internal rate of return if we can return that $1.5 million in just 2 years instead of 5 years. This becomes more interesting to the CFO. Okay, again, it's going to depend on where the company's hurdle rate is, but if this would be a typical company of, say, a 20% hurdle rate, then the CFO goes, yeah, that's a good investment. There's probably not a lot of places that I can stick my $1 million on behalf of the company and get a better return than this. And that's really the whole idea here of calculating internal rate of return. It is a more useful number than calculating the absolute ROI. Now, let's go back to the homework problem. So now that we know how we're going to calculate the estimate of the goodness of this investment, let's read about the challenge facing the company. Customers are calling in to customer service and often spend several minutes waiting on hold to speak with a human customer service representative, the CSR. The measured average time on hold is 5 minutes per call. Not a pretty picture. I think we can all already start to just feel memories of frustration for when we have to be put on hold for 5 minutes and we call in for customer service someplace. Not only is customer satisfaction going down according to our customer satisfaction surveys, but our abandoned call rate is going up. And we are concerned that some of these represent customers who may switch to our competition for service after they give up on us. So again, the abandoned call rate, these are people who hang up before ever getting to talk to a human being because they said, I'm not going to hold any longer. And then we're concerned that some of those folks are so frustrated at the end of that time that they're actually switching to our competition for service instead of us. All right, so IT has analyzed the situation and is proposing a computerized customer service system that they claim will speed up our CSR's ability to service our customers. All right, so let's look at the proposed IT project description. In preparation for this proposed project, the customer service group and the IT department have established the following metrics and measurements. There are currently 20 CSRs working full-time. The job function of these CSRs consists of taking a customer phone call and responding to customer requests, usually by looking up product information such as warranties, installation information, product specs, etc. The average customer service phone call lasts 10 minutes. Now that's not including the hold time. So after the customer finishes being on hold for an average of 5 minutes, then he's talking to a human being, the CSR, for another 10 minutes. Okay? An average of 8 minutes of each customer service phone call is spent actually doing the looking up of the product information. So we ask the question, so what's happening in the other 2 minutes? Well, what's happening in the other 2 minutes are things like, what's your name? When did you buy the product? What model? Maybe even what's the serial number? How's the weather in Des Moines today? And whatever else happens in the conversation between two human beings, the CSR and the customer. So our statistics show that once the customer service representative knows what they're supposed to be looking up, what information the customer is asking for, it takes an average of 8 minutes to find that information. All right, so now prototypes, industry research, and conversations with engineering and CSRs lead us to conclude that we can build an IT system that will allow the CSRs to find the product information they need in an average time of about 3 minutes. Okay, so this will reduce the average call time from 10 minutes to 5 minutes, while at the same time, it should reduce the average hold time from 5 minutes down to nearly negligible. Okay, we're estimating about 15 seconds. So let's ask the question, how does this make our hold time problem go away? Well, let me just show you a quick sketch of how that happens. Some of you probably already have this picture in your head, but I have learned from past experience that drawing this picture helps. As far as the customer is concerned, he's spending 5 minutes on hold. Okay, and then he's getting on the phone with the CSR. Okay, the CSR picks up the phone at this point. He spends another 2 minutes talking to the CSR and then waits 8 minutes, again on the average, for the CSR to look up the information. Okay, this is the 10-minute call plus the 5 minutes on hold. This works out to be a 15-minute telephone experience for the customer.